A2 Further Maths Flow Augmentation Algorithm. Okay, so what I'd like you to do, please, just using your skills from year 1, I would like you to have a go at seeing if you can find a maximum potential flow through that network. So what's the very best flow you can get from the source to the sink? So pause there, have a good play with it, see if you can figure out what's the best flow. Okay, so not straightforward, and you might not have got it right, but that doesn't matter. Right, if you'd managed to get a flow through the network like this, so flowing 25 and 16 through those two, they split up into 15 and 10. The bottom ones can split up into 7 and 9. The 15 at the top can split up to 4 and 11. Then everything that flows into D can then flow out, as long as they're equal. 9 and 3 flow into E, so there's 12 that flow out of it. And then you can fill in the last ones, because 11 and 7 is going to make 14. And 8 and 12 makes 20. So that is the very best flow, okay? And there was no easy way to do that. You just had to keep playing with the numbers until you got to this position. And you might get to this position and think, actually, how do I know that is the very best? How do you know that 41 is the very best flow through that network? So that's the next question. Have a think about it. How would you know that that is the very best flow? So just pause there and have a think. Okay, so there is a way to check whether your flow is the very best, and that is by looking at the cut. All right, the maximum flow, what we want to do is look at all the different cuts. So for example, if I cut straight from the source and separate that from all of the other vertices, and I cut it there, or the other nodes I should say, so I cut it there, I can see that cut there would be 46. So that flow from S to A and B would be 46. Whereas if I cut at the end, just here, then I would get 7 and 14 makes 21, plus 22 would make 43. Now 43 is a better cut than 46. There's no point in flowing 46 out of our source if the sink can only take a maximum of 43 flowing into it. So the smaller the cut, the better. Now your job is to look through that network and find the smallest possible cut. Okay, so that's what I'd like you to do now, please. Okay, so if you'd actually tried some different cuts, so I just talked about 2 there, what we're looking for is the smallest cut. And the smallest cut is actually there. Remember in this notation that the nodes on this side are all on the source side. So that's the source side. All of those are flowing onto the sink side. And the only 2 vertices or the nodes on the sink side are G and T. And if you look at that cut there, you've got 21, we've got 8, we've got 7, we've got 14. And if you add those together, you've got a cut of 41. And if we can find a cut and a flow of equal value, then we can apply the theorem that we saw in year 1, that the maximum flow equals the minimum cut. Therefore, that is the very best flow through that network. And you could stop then. That's it. You're done. The problem you have is, how did we actually manage to get these answers in the first case? You know, if you managed to get lower than 41, maybe you didn't get a flow of 41 through that. What do you actually do to improve it? Right? And that's what we're going to look at now. So first of all, I'd like to find what we call a potential flow. So just have a look back at our fresh network. There's nothing flowing through at the moment. And say I wanted you to get a flow of 24. Now that's a little bit easier. All right, a flow of 24. You could do it in multiple different ways. So I'm going to show you the way that I'm going to find it. I'm going to split up the first 2 values as 12 each. So that's definitely 24 flowing out of our source. And I can split them up however I want, but I did it roughly equally. So I've flowed it through there. Those split up there, and you notice that any given cut through it, if I look at what my flow is and I cut, I'll always get 24. So for example, in there, ignoring the maximum values, look at the values of these ones that I'm flowing through at the moment. 10, 2 and 12 adds up to 24. Okay, at any given point, 6, 6, 7 and 5 adds up to 24. So I've found what we call a potential flow through that network. Okay, now that is what we can take as our initial flow. Now this is something new. You haven't talked about this before. So at this point, I'd like to make sure you've got your notebooks out, please, so we can get some more information about what we mean by an initial flow. So an initial flow is any potential flow through your network, and it basically means a starting point. Okay, if you need a title for your notebooks, it's the flow augmentation algorithm, or how to augment flows. Put that down as your title. So an initial flow is some starting position. Where do we start from? Well, in this case, you've got a situation where you're already flowing 24 through that network. So you can imagine this in a real life problem. Maybe we've got some sort of gas network like this, and they already flow 24 through that gas network. Can they improve that? Now we know we can improve it. We know we can improve it up to 41. But at the moment you've got 24. So if you can improve it, what we're going to look at is how can we improve that? Just worth noting here as well, sometimes you start at a zero flow. So a zero flow might be same sort of situation. Let's say this is a road network connecting up lots of different towns, and we start off by having no cars on the road at all. We have all the roads closed, and therefore there is zero traffic flowing along those routes. And that would be a zero flow. Now a zero flow is still an initial flow, but it's an initial flow with zero along each of the routes. It's also just called a potential flow of zero. Okay, so some questions do start with a zero flow. Some questions might start with an initial flow of something more than zero. So a starting position where you might say, look, so far the network's doing this. Okay, so just make sure you've got what notes you need down. Pause if you need to. Okay, so what we're going to look at is something called the flow augmentation algorithm. And the flow augmentation algorithm basically improves on our initial flow. It augments the flow you've already got. Okay, so what we're going to do is we're just going to take some notes down about some of the notation you need, how to set up the network, and then we'll carefully go through how the algorithm actually works. So the first thing we need to do is actually have a go at redrawing the network. Okay, so we're going to redraw the network. Now, when we go about redrawing the network, we want to show both the current flow and what we call the potential flow. And the way we do that, if we just take any of the edges, so this edge here is an edge of 13, and we want to show what's flowing through at the moment and what we've still got able to flow through. And we do that by having what we call a backflow arrow. Now the backflow goes against whatever we had before. So in this case, if you look at this one as 15, the backflow will be going this direction. It's going in the opposite direction. And what we can do is we can put down there what we've got flowing through it at the moment. That's part of our initial flow. So in this case, 13, just for an example, let's say I flow 5 through that at the moment. Now the forward arrow, okay, so a forward arrow, just there, the forward flow arrow shows what is still remaining in the pipe. So we should have what's been used so far in our initial flow, and what is still remaining, what's still left over that I can still potentially flow through it. And we'll notice that when you put those two together, they should always equal the value of the actual pipe itself. We can flow 13. We've just separated it out into 5 and 8. Okay, so that's the difference between what a backflow is and what a forward flow. And it's very easy to get those mixed up. So just be very careful. All right, it's always important to think what's going in the same direction is always what we can still use. Okay, right, and as I just mentioned, the forward flow always equals, so this value here that we had initially on the grid always equals the maximum flow, sorry, the forward flow, this one here always equals what we've got there, the maximum flow through the pipe minus the backflow, or you could rearrange that however you want. These three are interlinked. Okay, so pause there if you need to, just take any notes down. So the forward flow flows through there. Okay, so what we want to do is just redraw that network. So we're going to redraw the network with each of the arrows blank, and now I'm going to add a forward flow and a back flow. So I'm completely ignoring what the flow was originally, and I'm making sure that I add these two arrows in. Okay, so each one has got those. Usually you're given a blank network to do that on yourself. Sometimes you might see that they actually use full lines. For each of the edges, they've a place for 2 full edges. You might see that in things like textbooks or other questions. Now it's simpler just to do 2 little ones, but it's totally up to you. You can do full lines if you prefer. So once you've got your network set up, so what I'd like to do is make sure that you draw that fully in, please, because I'm going to get you to do one or two of these yourself. We can transfer our initial flow of whatever we had onto our network. And remembering that each of the backflow arrows, so the ones going against what we had initially, are our initial flow. So in this case, have a look. We were flowing 12 through that pipe in that direction. Okay, so 12 flowing in that direction. So when I come to this grid, this network here, I want to change the direction. So it's a backflow, and that's what I'm going to put 12 against. Same with this one. Look, it's flowing from A to C. So my backflow, which flows from C to A, is 6. I'm putting on the red circle there, the potential flow, against the opposite direction. Always the opposite. And you need to be careful when you have things like potentially this one here or this one here, and make sure that you don't get the directions wrong. It's sometimes obvious when it's sort of obvious flows in this direction, but the ones that go like that, they can be quite tricky and they can trick you out. So be careful. For D to E, it's flowing downwards. So this is my backflow here. For C to D, it's flowing downwards there. So that's my backflow there. So be careful making sure that you get the correct ones. So there we go. I've transferred, just double check you're happy with that. I've transferred each of my initial flows against the back arrows just there. Okay, that's where those numbers have come from. And just to give you an opportunity to do the same, because once you've done that, you're going to have to do this part yourselves. Okay, so you've got your network set up. What we want to do now is showing on this network just here what's left over in the pipe. So for example, if I look at the moment and I say I want to flow from S to A, well, I know I can flow 26 in total from S to A, because that's what it says there, 26. But the problem is I've already used 12. I've already used 12 of it up. So I can't flow the full 26 from S to A because I've already used 12. So what's remaining in that pipe is going to be 14. So you're thinking about what you've used and what is left over. And that's why it's important to make sure you've got the backflow. Remember, the backflow is a bit like what's been used so far. This is the one that we want to be increasing. This is the one we can still use. Right, so what I want you to do is just go through and fill in all your backflow arrows of what we could still potentially flow from S to T. All right, so just pause there, have a go at filling them all in. Okay, so let's see if you've got them all right. Hopefully you did. It's just some basic maths, but it's also easy to make silly mistakes. So always double checking. 9 left over. 9 and 12 makes 21. What else? 9 and 6 makes 15. And you could go through. 6 and 4 makes 10. Okay, look at this one. 14. So I've used 7 to the 7. This one, 9. So it's got to be 5 and 4. So you can go through 7, 4, 6, and so on. All right, 2, 4, 4, 5 and 2 makes 7, 14, and 12 and 10 makes 22. So I've managed to fill in all my backflows. So my network now is complete. And what I can do now is I can start using this new network to create some additional flows. And this is where I'm going to start using the augmentation algorithm. So to augment the flow, what we're looking for is any flow that can still flow from source to sink. It doesn't matter how you do it, remembering that you can only flow in these arrow directions, but it doesn't matter which ones you use. So for example, I could do maybe 4 along here, 4 along here, and then I could potentially flow 4 along there. I could do that because I can flow it all through. But you could also do things like this. You could flow 2 through there, 2 through there, and 2 up here, because it says I'm allowed to flow 2. That's against the original one, but that doesn't matter anymore. Okay, you can actually improve flows by going against some of the original ones, and we'll see an example of that later. So what I'd like you to do, please, is just think of any flow, make it as big as possible, all right, because that makes life a lot easier rather than trying to just get ones of one. A big flow from S to T. Okay, so pause there, have a think about any flow. Right, so you might have got a different flow to me, but my example could be just a flow of 4 along the top. And I could have got a flow of 4 from SADT. Doesn't really matter. Okay, so I've gone across here, because I know I can flow 4 through there because I've got 14 left. I can flow 4 along there because I've got 9 left. I can flow 4 along here because I've got 7 left, but I can only flow 4 down here because that's all that's left in that pipe. That's why I'm restricted by this flow of 4. Fine. What I can do now though is make a note of that. So I can record these results in a table. And again, you may be given a table. It's quite likely you're given a table to use. If not, you can quickly sketch it down. So just to make a note, I'm flowing S to A to C to F to T, and that was an improvement by 4. Now I need to show that on my network. And the way I can show it on my network is going through each of these vertices that I've used, or sorry, each of the nodes across each of those edges, and correct and change them, augment them. So at the moment, I'll show you what I mean. I've got 14 left in this pipe, but I've used 4 now. So that's going to go down to 10, which means that this one is going to go up to 16. I've used an additional 4 from this flow, so that's why it's changed from 10 to 16, making sure that 10 and 16 still adds up to the original 26. Right, what else? A to C. A to C had 9 left in it, but now I've used an extra 4, so that's going to go down to 5. But now the improvement can go on this one, so 6 can go to 10. And you can go through and do the same here. I've gone from C to F, improvement of 4, so it was 7, but now it's down to 3. But that 4 could go down to up to 8. Okay, remembering that that's what's flowing through it now. It was 4 plus another 4 is 8. And also just to double check, 8 and 3 still makes 11. On this one then, I'm flowing an extra 4 through there, so that 4 there will go down to 0. But this is improved, so it's gone 10 up to 14. And there we go. I've amended my network and I've got this new flow of 4. And then once I've done that, I start it again. I look for another flow from source to sink. Remembering now, I've got a problem here that I can't flow anything more through this one. Okay, so that's it, done. It's been exhausted. Right, so what I'd like you to do, have a go, think about another flow from source to sink. It doesn't matter how you do it, any way you like, just have a think how you might do it. It's quite a good chance of being different to mine. Okay, so what I've opted for is S to B to E to G to T. I make life easy for myself. I just do straightforward flows. I don't do ones that go all the way around the network silly. I just do straightforward ones from source to sink. So I could flow from source to sink like that. Now, how much can I flow through? Well, I can flow 9 there, but I'm restricted to 4 here, and 10 there. So the best I can flow through this is going to be another value of 4. I can't flow any more because that one's restricted there and there. So go through, change the values. So 9 goes down to 5 because I could flow 9 through, but now I've used 4 of it up. So 12 is going to be improved to 16. 16 and 5 makes 21. On this one, I did have 4, but now I'm going to go down to 0. But that 5 can go up to 9. I did have 4, but it goes down to 0. But that 8 can go up to 12. And just think about what that means. It means now I've used 12 in that pipe and there's nothing left. That makes sense with the original drawing. Look, I've used the 12, there's nothing left in that pipe. What about this one? An additional 4 here would reduce that down to 6, but then that means that this was going to go up to 16. Noticing that 16 and 6 makes 22. Right, done it a second time, I can augment it again. Can I think of any other flows from source to sink? In this case, I can flow another one, S to B to D to T. What can I flow? Well, I've got 5 left in that pipe, 7 left in that pipe, 5 left in that pipe. I would say the best I can do is flow 5 through that network. So the best we got is a flow of 5 through that network. So what I can do is I can go through the same process again. I did have 5 in there, but now I've got 0. I have got 16, but that's improved to 21. So that pipe now is fully used. This 7 can be decreased to 2 because I've used an extra 5 in there, but of course this 7 will be improved to 12. And this one here can be reduced down to 0, but that 2 means it's gone up to 7. So again, just take your time with it, make sure you're picking the correct arrows and always double checking that these 2 add up to the maximum flow. 2 and 12 make 14, 0 and 7 made 7. Right, can I flow anything else? Well, I'm stuck now. Nothing else can flow down there, but I can flow some values still up here. I can flow 10 up there. 5 there, 3 there, but then it's stuck. I can flow 6 down here. So there is potential. I could do some really sort of complicated ones, but you're trying to keep life as simple as possible. So to me, maybe something as simple as that might work. So I'm doing S to A to D to G to T. And if I did that, I could flow 10 up there. Still got 10 left. That's good. 4 here. So I'm restricted down to 4. 4 here. So I'm restricted to 4. And I can definitely flow at least 6 through there. So another flow of 4 through that network. Right. Go through. Do all your mending. So it was 10. Now it's down to 6. 16 improves to 20. Okay. This one here, I have got 4, but that's going to go down to 0. That 6 is going to improve to 10. This 4 is going to go down to 0, but this 4 is going to go up to 8. And then finally, this 6 will go down to 2 left in it, but the 16 can go up to 20. And so now I've got everything flowed. And again, just double check, have a look, is there anything else you can flow through it? Well, you're going to get into a position where you can't flow things, because if you look, it doesn't matter what you flow up there, you're not going to be able to get anything else along this pipe just here because it's 0. You might be able to get 2 up there, but you can't flow anything down here because it's 0, or there because you've got nothing left in it, or there because you've got nothing left to it. So these zeros are really stopping you flowing anything else in that direction. All right, so you can't flow anything else in that direction. So there's no more flows from source to sink. So therefore you are in a position where you've reached the maximum flow. Now what we can do is we can look at our grid, and it is the backflow arrows that are the important ones. Because as we said, the backflow arrow, the ones that are working against, tell you what your flow is. So this is just 21 here. So I want to make sure that goes up to 21. Whereas this one, this is 20. So it wouldn't be 26. I would have that as a flow of 20. So just make a note of which is our best. There we go. So it's just saying there, find the maximum potential flow. We want to find the final backflow arrow values. So that's the 20. That would be the 21. That would be, just keep an eye on the direction, that would be the 10. All right, that one there, sorry. And that one there is 10. We've also got this one here, which is our 12. This one here, which would be our 9, because that's flowing in the opposite direction to that one. And you can go through and you can get which one. This one's be careful. The backflow there is 2. The backflow there was 3. All right, so that didn't change. That one there is 8. This one here, opposite direction, that is 6. Opposite direction of that one is going to be the 8, and so on, just for the last few. Okay, so we've managed to work out which one was all our backflows. Those are the very best flow through that network. So what we can do is we can now put that on our final drawing. So you have another drawing like this one, but instead of having the initial flow, we can now put on our maximum flow. There we go. No surprises, that is the same as the 41 we had originally. So we've got the same values. What we can do is we can check it, we can find the cut. And what's important about the cut is we notice that the cut is through the zeros that we've already got. Okay, so what is the maximum flow? Well, initially we started with 24, but now we've got an additional 4, an additional 4, an additional 5, an additional 4. So our maximum flow is 41. It saves you having to calculate from the grid, although it's not hard because we can see it there is 20 and 21 makes 41. Or you can use the initial flow plus all these extras on this table. Both of them get the same result, a flow of 41. Can you find the cut? Yes, it's where all the zeros were. So 0, 0, 0, 0, that is where that initial cut, or that minimum cut lies. Right, so there's a lot of easy mistakes to make with the augmentation algorithm. So you do need to take your time with it, you do need to practice it. Okay, and just be very careful, making sure you get your 2 arrows the right amount. Last thing you want to do is make a silly mistake and therefore lose loads of marks on it. Okay, so I'm just going to give you a moment, just have a look at this network. It's a very simple network, as you can see, with just 4 nodes, and just see if you can figure out what's wrong with it. What's wrong with it? Okay, so you might have noticed that the flow through it is 20, is just 14. There's 14 flowing through this. You can see there's 13 and 1. And there's nothing you can do to improve that. Look, you've got 13 flowing up here. That splits with 11 and 2. You've got just 1 flowing down here, but you can't improve that because there's only a 12 flowing through here and 11 already flows down. But isn't it a bit stupid? Because you can just flow 8 down there and 9 across there, and it's definitely better than 14. Okay, that would be what, 9 and 8 makes 17. It's a very obvious, don't use that middle bit at all, and you will be able to improve it. Okay, in fact, you probably could improve it even more because you could flow a bit through there. So we're in a situation where they've already got an initial flow, but you can't improve on that initial flow at all, but unless you completely restart that initial flow. So there is a problem with the network. But what's good about the flow augmentation algorithm is it actually sorts out problems like this. Now, this one might be really obvious, but you imagine if you had a big network and this is a problem somewhere within it, and you can't easily tell that there is an issue with you overusing one of the edges. So how can we do it then? Well, yes, that's what I just said. Should not have a flow of 11. You can decrease that as much as possible. But if we just take the flow augmentation algorithm and we have a look, so it's a bit of a simpler version. So there's our initial network. There is us amending our network ready to use the flow augmentation algorithm. Now, from the previous one, we can put on our initial flow. So our initial flow looked like that, and we can see that there was a problem with it. Now notice now that we can also put the other bits on. So we had 0 left in there, 7 in there, there was 0 left in there, 7 left in there, and 0 left in here. Okay, so that was my initial flow and me setting up what's left over. Right, now if we do the flow augmentation algorithm, we can get from source to sink. We want to get from A to D. Now what's important is we can use any of the directions. So before we couldn't flow any more out of this one, and we still can't. We still can't get from A to B, but we can get from A to C, which was we could do before. But we can't get from C to D. But look, this is where it's important. This is where it actually helps. When we flow from A to C, we can now flow from C to B. That goes against the original direction, but what you're doing is you're improving this 11 here. You're cancelling out the mistake and you're improving it. So what I can do is I can flow a flow of 7 from A to C to B to D. And if I flow a 7 from A to B to D to D, I can change that to 0, but that means that improves to 8. This one here can go down to 4, but this one changes to 7. They still add up to 11, we can see that. This one's going to go down to 0, and this one goes up to 9. And what that means is now I've finished. I can't flow any more through there, and I can't flow any more through there. It is complete. So I completed what I had before. And if you remember what you had before with the 14 plus that 7 should get you a maximum flow of 14 plus 7 equals 21. Even though we couldn't do it initially because there was a mistake and we had to correct the mistake, the flow augmentation algorithm sorts that out for you. It changes that 11 that you had originally to 4, and now you've got your maximum flow, and you can find a cut for that value. And there we go. There's a simple cut separating the nodes A, B, and C from the node D, and that gets you a cut of 21. Hence, that is the very best flow through the network, a flow of 21. Okay, so what I'd like you to do is just have a go at practicing some of those exercises on page 84 of your discrete textbook, exercise 5.2.